Today's lesson is gonna be an easy one. Okay, I've decided that Mondays are always gonna be like an easy, more like a discovery type lesson. Okay, because we finished a lot of the stuff with the triangles, and technically now we have to start a different topic with the triangles, which is trigonometry. But before we actually start, every single time I start, it kind of starts very difficult, because we're just jumping into the math. No, today we're just gonna jump into the discovery. Okay, so all I want you to do today is basically sketch triangles and measure them. So, first thing, everyone, listen up. Do not feel that you actually have to create the same triangle I'm gonna create right now. Okay. By the way, do not do anything. I'm gonna run through the whole thing, and then you can create your own. So the point of today is to sketch a right triangle, any right triangle, and you just got it. So let's start. So in the space below, and I even gave you a grid to make it easy for you to sketch a perfect 90-degree angle, using a ruler and a protractor to sketch perfectly. So it's not just an approximate or like a rough diagram. Today needs to be as perfect as you could make it. Okay? Sketch any right triangle you like. As long as it has a 90-degree angle, it can have any other two angles you want. Obviously, the other two angles themselves have to add up to how much? Why? Because then 90 by itself and two others that add up to 90. What's 90 plus 90? 180, which is absolutely any triangle. Sure. So for example, you can have the other two angles. You can make it 10 and 80. So there should be a degree sign there above the 80, 20 and 70, 37 and 53, 40 and 50, whatever you want. Okay. Also, please use as much space as you can. All right. So this box, if you can make your triangle as big as you could right before touching the edges, that is absolutely what we need. Once you're done sketching the triangle, cut it by sketching a vertical line somewhere in the middle, anywhere. And then finally, put all the numbers inside and outside. Inside, you can only put the angles. Outside, you can put the what? The side length. Okay? So let me show you what I mean. So I'm going to sketch. Let me just sketch a triangle here. There we go. So I'll randomly go with this. You can make it like that, everyone. You can make it like this. I mean, technically here, you're not utilizing the whole space, but at least you're using this much space, okay? You can make it like this. You can make any triangle you want, as long as this angle is how much? 90-degree triangle, okay? So let's say for today, I'm gonna go this much, okay? So do not feel like you have to fill in the whole space. Just make sure at least you fill in horizontal space or vertical space. So like, even if you make it this thin, that's okay with me. And if you make it this as well, that's okay too. If you want to make it this big, sure, no problem. So randomly, I'll do this. And let me make sure that it's not filled on the inside. So shape fill is no fill. And it's in black. There we go. And I'll make it one. Okay. All right. So what do I need to do now once I sketched it? Come on. What's the first thing? So once I sketched it, okay. Once you're done sketching the triangle, I need to cut it somewhere. I can cut it here. I can cut it here. I can cut it here. I can cut it anywhere I want. So I'll choose to cut it. I don't know. I'll choose to cut it. I still need to insert a line, a straight line. I'll choose to cut it this way. I'll have to make it perfectly straight. Okay. And I'm going to make it a thick line like this. There we go. How many triangles did I just make right now? How many triangles do you see right now? Two. You've got the small one, like the ones we did for the similar triangles. This one and this one as well. Okay. What does it say then? I have got to measure the what? This angle. By the way, do I need to measure this angle? Come on, wake up. No, because this 90 by what? By construction. I made it 90. I need to measure this angle and also what? This angle as well. All right. So how do you measure? How many people know how to use a protractor? Okay, let me just run you through a quick crash course in using protractors. Okay, so let's see. I'll zoom in. Okay, how do I measure angles? I have to move this one. I can make it smaller if I want it. I'm going to move it. There we go. Down, 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 down. Okay, here it is. You have to put, everyone, you have to put this exact point on here. So can someone tell me how big is this angle? I'll zoom in for you to see. How? So okay. So obviously, what's the number here? What's the number here? 180. But actually, we don't use the 180. We use the what? 0. Okay. So 0, 10. 10, 20, 30. What would that be? Yeah. 31, 2, 3, 4, 5. 30 what? 30. By the way, it's between 36 and 37. So feel free to use 36 and a half. Feel free to even make it 37. Okay. So I'm just going to say 36 and a half. By the way, everyone, this line could be here. You could have the line here. You could actually have the line anywhere you want. Obviously, if it's here, it has to be shorter. Sorry. If it's here, you have to make it like this. Okay. But you can make it anywhere on the what? Anywhere in the triangle. Anywhere. Okay. If you're done, then you have to what? Now you have to start measuring what? All the sides of the triangle. This is what I mean. You have to measure this side. So you have to measure this side, and this side. That's only the small triangle. On the big one, you have to measure this side, well, of course you can see it, and then the entire hypotenuse. Go. I shouldn't have that, but I should have. Okay. So whenever you hear the words opposite or adjacent, by the way, is it easy to know where the hypotenuse is? Where is the hypotenuse all the time, 24/7? Where's that? Yes. So where is it? Is it the longest or the shortest side? It's the longest side. That's usually tilted, like this one or this one. What about the opposite? Okay, everyone. When you say opposite, you have to tell me. Listen up, everyone. Pencils down, because this is basically the beginning of tomorrow's lesson. Okay, we're just leading up. Whenever you want to say which side is opposite, you have to tell me which angle you're looking for. Sorry, you're looking at. Are you looking at this angle? Or are you looking at this angle, like within a triangle? Are you looking at this one or this one? Or in the big one, are you looking at this one or this one? The only angle you never care about is the what? You just need it to what? You just need the what? The 90 to what? To be there. You see what I mean? We never, by the way, we never use the 90 in trigonometry. We never do. We just need it to what? We just need the 90 to be there, which basically, listen up, is one important take-home message. You cannot apply trigonometry unless your triangle is what? Unless your triangle is what? Come on. A right angle triangle with 90 degrees. If it doesn't have 90 degrees, you cannot apply anything I'm going to teach you tomorrow, Wednesday, Thursday, even Friday, okay? You can only apply it if you can see a what? A right angle triangle. Okay. So that means once you see the right angle here, you say, good, I'm going to choose one of the other angles to look at. I always like to look at the one on the ground. I don't like to look at the one where here, although you can. So everyone, I want you to circle this angle today. Go ahead, just circle, just put a circle on. By the way, how many people have this angle already measured? How many people measured the angle? This needs to be measured right now. Go ahead. So I'm going to circle it. Just circle it. Don't put any A or B or C. Don't label, nothing. Today we're not labeling. Tomorrow we're labeling. Today we're not. Okay. So I'm going to use this angle right now. Okay. So can someone tell me in the small triangle, everyone, do not look at your paper. Look at the screen. And this in the small triangle, where is the hypotenuse? Can you see it? Where is the hypotenuse? In the small triangle. Yeah, it's the distance from here to where? To here, right? Good, perfect. Can someone tell me now, in the small triangle, where is the side opposite to this angle? Opposite to it. Is it the horizontal one or the vertical one? It's the what? It's the by the way, whenever your angle chosen is this one, the one opposite to it, opposite, right in its face. If you just walk, which one do you hit? You hit this one. So this one is opposite. So that leaves which one to be adjacent? In the small triangle. You've already known the hypotenuse. You've already known the opposite. Haley, which one is left to be the adjacent? Yeah, thank you, the base, or the horizontal one, or the only one left out. Good. Can we do the exact same thing for the big triangle? 100%. Where is my hypotenuse for the big triangle? It's all of this from here all the way up to here. How about the opposite in the big triangle? Imagine if this line does not exist. Imagine if this line does not exist. Where is the opposite in the big triangle to that angle, 36.5? Same exact one, just the bigger vertical. So where is the adjacent in the big triangle? Where's the adjacent in the big triangle? Again, imagine if the blue line is not there. Exactly. So vertical or horizontal this time? Exactly, horizontal. So all of this one. Perfect. So all I want you to do now, since you know which one is opposite and which one is hypotenuse and every one, you have to what? You have to make this fraction. But before you do that, what's up? Go ahead. Everyone listen up. No, okay, okay. Good. By the way, opposite, hypotenuse, and adjacent, these three words only mean sides, not angles. Do you see what I mean? So everyone, Hamza saying, but wouldn't this angle be opposite to this angle? Sure, it's opposite as an angle, but opposite and hypotenuse and adjacent never refer to angles. They refer to what? They refer to size. So they refer to either this guy or 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 this guy. These what these three words mean. So now we can what? We can label everyone. So go ahead. Let's put, that's why I told you to sketch big, because we're going to put more words on this triangle. I want you to put OPP here. OPP. By the way, never use the full word. OPP stands for what? Opposite. And then, let me just do it in black so everyone can see. So OPP. Also, this one is what? This one is also OPP, but for the what? For the big triangle. Nice. Okay. How about the adjacent? Yeah, it's gonna be tricky because the adjacent is kind of cut off. But you can put ADJ here, and you also can put ADJ here as well, like this. How about this one? This becomes what? This becomes what? Come on. Hypotenuse, and also what? The big one becomes also what? The big one also becomes hypotenuse. You don't need to show this length. By the way, good news. I'm never going to give you two triangles inside of each other. So you're not going to have this mess of labeling. It's only going to be one triangle. I'm just showing you why trigonometry works. Okay. What do you do now? Not much. You've already have your numbers. Go ahead and what? Put a fraction and then show me the decimal. So I'll choose one of yours to do. Let's take Muhammad. Muhammad, I'll do again. Do not write these numbers. These only apply to what? To Muhammad's triangle or triangles. Okay, Muhammad, tell me in the small triangle. Tell me in the small triangle, how long is your hypotenuse? In the small triangle, go ahead. In the small triangle, how big is this length? How big? So you're telling me how big this one is, right? Like this one. Sorry, 1 second. You're telling me how long this one is, right? Yeah, this is the small hypotenuse. This is the small hypotenuse. How much? Okay, hold on. How much? So 10.3. Damn it. Okay, just give me 1 second. I have to change the layout. There we go. Now we're good. You said 10. Okay, 10.3. Okay, can you tell me what's the opposite in the what? In the small triangle, like this one. So you're telling me now this one, right? Perfect, 7.2. Okay, 7.2. Okay, go ahead, keep going, Muhammad. We already know hypotenuse, it's 10.3. Can you tell me now what's the adjacent in the small triangle? Again, everyone, these are not your numbers. These are only Muhammad's numbers. So you're saying this from here to here, 7.2. Okay, I'll take 7.2 as well. Interesting. So Muhammad apparently used what? Made a 45 degree, right? Like you almost made this. Great, no problem. Now, do you think I need to ask Muhammad for these ones? No, I don't. Because I already know the opposite from here, and I already know the adjacent from here. So it's 7.2 and 7.2. Okay, let's work out the what? I want you to round to 2 decimal places. Okay, I guess I need this now. And I'm going to move it here so you can see what I'm going to do. Okay, look. All right, I need 7.2 divided by 10.3. How much is that? Okay, it's 0.699. If you cut here, what does it become? It becomes 70 or 0.70. Thank you. So 0.70. How about this one? Would it be the same or different? It's based on the same numbers. It has to be exactly the same. How about 7.2 divided by 7.2? What's any number divided by itself? Yeah, $10 by 10 people. Each one gets $1. So that means that's a 1. Perfect. So actually, you're right. Thank you. Technically, everyone, again, I'm not going to take marks off if you don't do that. But technically, I have to show 2 decimals. So I have to show 1.00, even though you say it's the same as 1. I do agree. But as far as rounding is concerned, yes. What's that? So, okay. So this one is the adjacent. So right here. This one is the opposite. So right here. And this one is the hypotenuse. So right here. Okay. So opposite. So 5.7. Oh, sorry, 5.2. Oh, how much is it? Yes, that's correct. How about adjacent? How much? 8.2 divided by 9.7. Yeah, you're good. Okay. Muhammad, now I want you to what? Tell me the measurement for the what? For the big triangle. Exactly the same way. All right. Tell me what your hypotenuse is for the big triangle. The whole thing from here all the way up to here. How much did you get? To the best of your measurement. Hmm. Sorry, how much? Like how big is the hypotenuse for the large triangle? The whole thing. 14.9. Okay, perfect. Hamad, what was your opposite in the big triangle? Or basically, this guy. 10 point? 10.7. Okay, 10.7. Okay, tell me now, I already got the hypotenuse from you, thank you. Tell me now what was the adjacent 10 point, 10.5. It's interesting because technically it should be the same as what? Do you see what I mean? If those two are the same, those two also have to be the what? The same. But you know what? Again, with measurement errors, these things happen. So okay. Do you want to stick with 10.5? Great, no problem. By the way, I'm not saying this one is wrong or off. Maybe this one is off. You never know. Okay. Sorry. Uh, 10.5. Okay. How about this one? Well, the opposite is from here, 10.7. And this one is what? 10.5. Okay. Let's see the decimal. Let's see the decimal. All right. I'm going to move it here now. Okay. I'm going to see how long how much 10.7 is out of 14.9. 10.7 divided by 14.9. What is this to 2 decimals? To 2 decimals. If you cut it right, if you cut it right here, would it be 0.71 or 0.72? 0.72 because the 8 bumps up. Nice. So 0.72. All right. How about this one? Clear. 10.5 divided by 14.9. What would that be? 0.70. Thank you. 0.70. How about this one? That's got to be slightly over 1. Just slightly, because 10.7 is bigger.
Interruption teachers, they are ready for, sorry, students with the last name A, grade 11. Go down.
Okay, hold on. Okay, sorry. Okay, what would this be? 1.04 or 1.05? Come on. 1.05, because the 9 is got bump it up. 1.05. Okay. What do you conclude about these numbers? Are these numbers almost the same? Are these numbers almost the same? Are these numbers also almost the same? Why are they different though? We know that they should be perfectly the same. Why are they different? Say again? Exactly. Are you sure that your angle measurements are perfectly perfect? Or are you slightly off? Angles. You can, by the way, I don't care how good you are with measurement. You still have to what? You still have to zoom in. You still have to squint, and you still have to what? Estimate, right? So you are never 100% correct. Also with a ruler. What's up? No, no, but in general, are you always able to measure perfectly? No, because you have to what? You have to approximate. And that's why you're off. Okay? The take-home message from today, by the way, that's the last thing I'm gonna say. The take-home message from today is if two triangles are similar, if two triangles are similar, is the opposite of our hypotenuse from one should be the same as the opposite of hypotenuse from the other? It should be if we really perfectly measured everything. How about adjacent over hypotenuse? It should be the same from the other one. How about opposite over adjacent? It should also be the same as the other one. And that builds up what we're gonna do for the next 4 days. Okay, that's it. That's today's lesson. I just want you to what? Discover it before we even talk the big words tomorrow.